So, very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the participant branches and class 8th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 8, our ongoing 6th chapter, electric current. And today we are entering into the session number 4. So far we completed 3 sessions in understanding the basic concepts and applications of electric current in our day-to-day life. So this is the total chapter, is the syllabus for the test number 6, which is scheduled for 30th December. This is a gentle reminder for all of you. So we have the test number 6 on 30th December. Chapter syllabus is this total chapter, electric current. We are going to get 2 or 3 more sessions before completing the chapter. But we'll continue where we stop in the last class. But before that, let us recall what we learned in the last 3 sessions of electric current, right? So when you see the slide here, you can understand the total things what we learned so far with a colorful pictures you can see. So we learn about we started with the history of electricity, that is how the electricity word came 2500 years back by the great Greek philosopher Thales introduced the word. Then he already introduced about what are the electric charges, how many types of charges are there, like positive and negative. Then what is electric current, electric potential, potential difference. And in the last class, we discussed about the Ohm's law, which introduced a new word called resistance. So we discussed about resistance also. So Ohm's law is the relationship between electric current and potential difference, right? At constant temperature, the potential difference between the 2 points of a conductor is directly proportional to strength of current. V is directly proportional to I at constant temperature. This is very important. You have to mention this. Condition is temperature. From this, you got equation V is equal to IR. Very famous formula, right? So V is equal to IR, where R is known as resistance. Resistance is the property of conducting material to control the flow of electrons, which is symbolically represented like this, speed breakers, and measured in ohm, right? So opposite to this resistance is conductance. Already we closed it, conductance. Conductance is nothing but the ability of conducting the current. Conductance, right? Which is measured in reverse of the ohm. That is, conductance is called 1 by R. Reciprocal of resistance, which is measured in units called 1 by ohm, or ohm inverse you can call it as, or you can say MHO also, reverse order you can write, that is reverse of ohm, and also measured in Siemens, again scientist name. Conductance also measured in Siemens, right? So these are the topics we discuss. So today we are going to discuss about what are the factors. Already we have seen outlines. What are the factors influencing the resistance? How the resistance changes? So there are 4 factors are there. One is length, second one is area of cross section, third one is the temperature, and fourth one is the nature of the material. Whether you are using copper or aluminum or gold or silver, which are the good conductors. Based on that also resistance value changes. That today we are going to discuss about what are the factors influencing the resistance offered by a conducting material, right? So by end of the day, we are clear about the loss of, they are called loss of resistance also. So electric current we discussed, electric potential, the potential difference, everything we covered, electric potential and potential difference, V is equal to W by Q. Now in last class we discussed about the Ohm's law, right? Then what is the electric resistance we introduced, and this is the Ohm's law circuit. How to verify the Ohm's law, how to verify that V is equal to IR, or how to verify R is equal to V by I. By using this, you can come across when you go to 11th standard in laboratory, we need to do the practical experiment for this. Then finally conduction also we discussed. Reciprocal of resistance is called conduction. Now today's topic, the factors affecting the resistance of a conductor. On what factors the resistance depends? There are 4 are there. Length of the conductor, area of cross section of the conductor or thickness of the conductor, temperature of the conductor, and nature of the material of the conductor. These are the 4 important. They are also called as laws of resistance. Right? According to the laws of resistance, the resistance offered by a conductor is directly proportional to its length, equation 1, and is inversely proportional to area of cross section, that is thickness. It is also directly proportional to temperature, and it depends on they are physical factors, resistance, temperature, and material, directly proportional to material, or in whatever it may be, changes. So these 2 are the practical applications factors. These are the physical factors. Okay. So all these are together called as laws of resistance. But we can consider this as a physical. We cannot do any mathematical things with the temperature and nature of materials. But these first two are called as, when you combine both of them, you can write like this: R is proportional to length by area of cross section. So what is area of cross section? Thickness. If thickness of wire is more, electrons will flow fast. Thickness is more, resistance is less. Thickness is less, resistance is more. Similarly, length. When length of the resistor is more, they control. For example, see, we have small speed breaker in front of your school. If anybody is coming by bike, they won't stop. They'll go fast only. If the length of the speed breaker is more, for example, one speed breaker is like this, one speed breaker is like this. So definitely, the second speed breaker will control the speed faster than the first one. Correct or not? When speed breaker is very small, anybody will move fast. They'll jump and go. But when speed breaker is very long, definitely they stop, they slow down the speed and go slowly. Similarly, resistance also same. Greater the resistance, greater the length of the resistor, greater the flow of controlling the flow of electrons. Similarly, thickness. When thickness is more, resistance is less. For example, simple logic I will tell. When you are cleaning your room with water, maybe in some corner you can find some hole, small hole, to send the water outside. Correct or not? If the hole is small, you have to apply more force to send the water, because resistance is more. If the hole is big, water will flow easily, because resistance is less. Similarly, here also, when thickness of the conducting wire, whether it is a copper or aluminum, gold or silver, if thickness is more, resistance is less. Area is more, resistance is less. Area is less, resistance is more. So these two together combined, you can write like this. So from this again, to remove the proportionality symbol, use the constant rho. Rho L by A. So what is rho? Rho is equal to RA by L. Just I taken the A this side, L this side. So formula we got for rho. What is that rho? The constant introduced here. Rho is nothing but resistivity. The rho is called resistivity or specific resistance. Very important word discovered here, which comes from the factors of the specific resistance. Rho is equal to. Right. So from the factors influencing resistance, we derived a new word called resistivity or specific resistance, which is given by RA by L. So you know R is nothing but ohm. We measure in ohm. A measure in meter square. Area, length into breadth. Length measure in meter. Meter cancel. So ohm meter is the unit for rho. Ohm meter or ohm centimeter for resistivity. So resistivity is the word derived from the laws of resistance. As per the laws, the resistance depends on the mainly two factors: length of the conductor, area of the cross section, that is thickness of the conductor. Of course, it also influenced by temperature and nature of material, but these two are the main factors. Okay, from that we got the formula rho is equal to RA by L, or R is equal to L by A. From R is equal to L by A, we got R is equal to rho into L by A. So by combined, you can see here is given. Right. So to remove the proportionality symbol, use the constant rho, which is called resistivity or specific resistance. So whenever area of cross section of the conductor is doubled, resistance become half. Right. When length is doubled, area become double. Sorry, resistance become doubled. So from that we got this one. Then how temperature will affect? Effect of temperature. So temperature increases, resistance also increases. So resistance is directly proportional to temperature. When temperature decreases, what happens? All the molecules will come close. So resistance increases. Does not allow the current to flow. But when you increase the temperature, all the molecules move randomly here and there. Okay, there is a change in the resistance when you are altering the temperature. Okay, so before going for the further explanation, I'll show one video on this resistance and loss of resistance, right? Then we'll move to the next part. Okay, yes.
Resistance, Ohm's law, and how to pick a resistor to limit current in an LED circuit. In previous videos, I talked about how voltage can behave like a pushing force, pushing electric current around a circuit. But in one example, I connected an LED straight to 7.5 volts. Way too much current flowed and the LED blew up. So you can see how it would be useful if there was something that could resist the flow of electrical current, something that could tame the flow in a controlled way. That device is called a resistor, and here are some examples of what resistors can look like. We've got a very basic resistor over here, which is the kind of resistor that most hobbyists would use at home when constructing circuits. And over here we have a tiny surface mount resistor. This is something that you'd expect to see in a small device like your phone. And this big resistor is the type of thing that you'd use in a large power supply. So how do these resistors work?
Electronic devices.
Remember how in my video about current I talked about electrons jumping from atom to atom all at the same time like a conga line? Well, in reality this process is not 100% efficient. The atoms in a material like copper wire are always vibrating around just a little bit, and this is because of the heat energy that they have. When electrons try to move through the wire, sometimes they'll bump into an atom that's in the way, and effectively the flow of current gets resisted. As this happens, some of the kinetic or movement energy from the electrons gets converted into heat. And this is the fundamental principle behind how electric heaters and incandescent light bulbs work. But it's not just metals that have the property of resistance. Resistance can exist simply from the fact that some materials just don't have a suitable arrangement of atoms for electrons to flow through. And some materials just don't have enough free electrons floating around for large amounts of current to flow. Keep in mind this is a huge simplification, and this is not how actual atoms and electrons are going to look and behave at the subatomic level. Nearly everything on Earth has some resistance to electrical current, and metals tend to have the least resistance.
Time to waste. Close your eyes and jump into our wildest dreams.
computers are born. Resistance is futile.
Sorry, I had to put it in the video somewhere. We measure the amount of resistance with a unit called ohms. The symbol is the Greek letter omega. To give you a sense of scale, a resistance of under 1 ohm is considered to be very low resistance. That's something that you'd expect to see from a piece of wire that's good at conducting electricity. 1 million ohms, or 1 mega ohm, is generally considered to be a very high resistance. That's something that you might expect to see from a bad conductor of electricity, like this dried out piece of carrot. This thing that I'm using to measure resistance is called a multimeter, and it can measure the resistance of almost anything. I have a separate tutorial on multimeters, and I recommend you watch it as soon as possible to learn more about this important tool. Now, if you're playing with electronics at home, you'll be using resistors that look like these. They have colored bands on them, and there's a special code that lets you translate the colors into a resistance value. For example, these red, violet, brown, and gold bands mean that this is a 270 ohm resistor. Now, you can memorize the color code, but it's a lot easier to just use one of the many resistor calculators out there. Just search for resistor color calculator on Google or in your phone's app store. By having resistors with specific resistance values, we can carefully control the amount of current that flows in a circuit. Today, let's start out with everyone's first simple resistor circuit using a resistor to limit the amount of current going through an LED. Make sure you've already watched my LED tutorial and have bought some resistors and LEDs, which I'm going to link again in the video description section. In order to do the math for this circuit, you need to know about the mathematical relationship between voltage, current, and resistance. Here's an old comic that I've always liked that illustrates this relationship on an intuitive level. More formally, we use this equation, Ohm's law. In textbooks, you usually see it written as V equals I times R, or voltage equals current times resistance. If you use a little algebra, you can rearrange the equation to calculate any of the variables as long as you know the other two. Although it's important to understand that all these variants of the equation are the exact same thing, our LED circuit is going to be using this version, so let's focus on that. Let's say we have a 10-volt power source, and we want to make sure that no more than 10 milliamps flows from it. We can use Ohm's law to figure out what resistor will accomplish this. The answer is really simple. Just take the voltage, divide it by the desired current, and we get the answer of 1000 ohms. So now we can either use the resistor color code or a resistor calculator app to figure out what 1000 ohm resistor looks like, and it turns out to be brown, black, red.
Right.
The fourth color band all the way on the right refers to the tolerance.
So what we can see is about the resistance there and how resistance will affect the flow of current. So factors are very clear that whenever the length of the resistor increases or length of the conductor increases, resistance also increases. Whenever the thickness of the conducting material increases, resistance decreases, which is inversely proportional. From that we got the very important term resistivity or specific resistance, which is measured in ohm meter or ohm centimeter. These are all together called as laws of resistance. All the four factors. Out of these, two are the practical and remaining two are the physical factors. So resistance offered by any conductor depends on length of the conductor, area of the cross section of the conductor, that is thickness, temperature of the conductor, and fourth one is nature of the substance of the conductor. Right? With these four, it impacts the resistance based on our requirement. We'll use the resistors in various motherboards of computers, laptops, TVs, and all. Okay. But all keeping all this in mind only, they prepare the resistors of particular ohm. It may be 1 ohm, 2 ohm, 3 ohm, or milli ohms, micro ohms also available as per our requirement. Okay. So this is complete picture about the electric current. Now the next part, what we are going to discuss is what is the effect of electric current. That we'll discuss in the next class, but just I'll give some glance ideas about the, okay, what is the effect. Next part is our next 2 days, we'll discuss about effects of electric current. Right. So what happens when electric current passes through a conductor? So we are enjoying so many life, so much lavish life with electricity. Like one is heating effect, right? One is lighting effect, right? One is chemical effect and the magnetic effect. Sorry. And finally, we have electromagnetic induction is also one of the effect. So whenever electric current passes through a conducting material, we can find all these effects. Each and every effect is having its own applications in our day-to-day life. Means all the electrical devices which we are using in our day-to-day life are influenced by one of this effect only. One of this effect. For example, if you see first one, heating effects of electric current. You know, every current carrying conductor produces heat. When you pass electricity to the bulb for 5 minutes and touch the bulb, definitely you can feel the heat. Because heat we cannot see, only you can feel. When you pass the current to iron box, you can touch that one, it becomes heat. When you pass the current through geyser, water becomes hot. Right, all these are the effects of electric current. Means all the appliances which works on the heating effects of electricity. So many we use in our day-to-day life. Geysers, kettle, heaters, room heaters, geysers, all these are comes under the appliances which works on the principle of heating effects of electricity. Similarly, lighting, you know everything. When you are passing current, bulb will glow, tube light will glow, LED will glow, light emitting diodes, CFL bulbs are there, which also converts the electricity you are supplying into light energy. Means here what happening? Electrical energy is converting into light energy and giving out the light for us wherever we require. It may be focus lights or lights in the stadium or our bulb, tube light, LEDs, CFLs. That is the effect of current. Chemical effects. Whenever you are passing current through chemicals, liquid chemicals especially, liquid chemicals, which are called electrolytes. What happened? They decomposes. The chemicals are decomposed into component ions. By that process is called electrolysis process, which is having the enormous applications in the industries. For example, when you go rolled gold articles, 1 gram gold. What is the meaning? Gold coated with the one metal over the other. Electroplating, that is called. Over one metal, we are coating with other metal. This is stainless steel. What is stainless steel? Over the steel, we are making chromium coating, plate, or anything you are using, utensils, kitchen utensils. All these are made by coating only. That is called chemical effect. With the help of chemical effect only, we are coating one metal over the other, which is called electroplating. Right? Magnetic effects, wonderful applications again. Whenever you are, every current carrying conductor produces magnetic field. This is also used in electric bell, cranes, and motors. So many are there. Water, pulling the water. How the water is coming from ground to the tank because of the magnetic effects of electric current. And generators works on electromagnetic inductions. Means whatever electricity we are using to do the work, it may be in the form of heating effects, or maybe in the form of lighting effects, or maybe in the form of chemical effects, or maybe in the form of magnetic effects, or in the form of electromagnetic induction. So in various applications, you can see in our day-to-day life how the electricity impacts, affects our life. Got it or not? So very clear that electric current is very applicable, most applicable in our day-to-day life in the form of either light, in the form of either heat, or in the form of chemical, or in the form of magnetic, or in the form of electromagnetism. Okay. So in next class, in details, we'll discuss about what are the effects one by one and their effects also. Okay. So right now, we'll conclude the class with the home task. You can see there, influencing the resistance, factors influencing resistance. So mainly you can mention the 4 factors, name them. The factor number 1, length, right? Factor number 2, area of cross section, means nothing but thickness. Cross section is this one, cross ending, area of cross section. Number 3, temperature. Number 4, nature of material. Right? These are the 4 important factors, out of which 3rd and 4th are the physical factors, they are called. And you can add them also. R is directly proportional to L. R is inversely proportional to area of cross section. A, if you take capital. By combining 1 and 2, we can write R is proportional to L by A, or R is equal to rho L by A, or rho is equal to RA by L. Very, very important relation. We'll come across so many problems on this, based on this, in higher classes, in IIT also. Where R is the resistance, A is the area of cross section, L is the length. Where rho is nothing but specific resistance. New word again, specific resistance or resistivity, it is also called. Resistivity of the resistance means the capacity of resisting the electrons, which is measured in ohm meter or ohm centimeter. Very small means centimeter can measure. Right? Clear? These are things what we learned today's class, completely about the laws of resistance. Okay. So thank you, Ramnagar. Right. So we'll continue the same in next class with the various effect of electric current and applications in our day-to-day life with a colorful explanation and video. Right. So note down this homework for today and write the homework in your notebook and take the signatures from your parents and subject teachers. And you can watch the same videos of recorded class of all the chapters through your YouTube channel, YouTube. Right. So that's all for today. Thank you, all of you. Have a wonderful day. Thank you.